How does the orientation and magnitude of tectonic stresses affect the type and style of deformation in rock formations? The orientation and magnitude of tectonic stresses can have a significant impact on the type and style of deformation that occurs in rock formations. Tectonic stresses can be broadly categorized as compressional, extensional, or shear, and the deformation style that results from these stresses can range from brittle fracturing to ductile flow. In compressional settings, where tectonic stresses act to compress the rock formation, deformation is typically characterized by folding and faulting. In this type of setting, rocks are often subjected to a combination of compression and shear stresses that can lead to the development of thrust faults, folds, and cleavage planes. The orientation of these structures can provide important clues about the direction and intensity of the tectonic stresses that caused them. Extensional tectonic settings, on the other hand, are characterized by the stretching and thinning of the rock formation. This type of stress can lead to the development of normal faults, grabens, and horsts. In these settings, the orientation of the faults can indicate the direction of extensional stress and the magnitude of displacement. Shear stress settings are characterized by horizontal movement of rock formations, often resulting in the development of strike-slip faults. The magnitude and orientation of the stress can determine whether the faulting is characterized by lateral movement, compression, or extension. In addition to the type and style of deformation, the orientation and magnitude of tectonic stresses can also impact the mechanical properties of rock formations. For example, rocks that are subjected to compressional stresses may become more brittle and prone to fracturing, while rocks subjected to extensional stresses may become more ductile and capable of flowing. Understanding how tectonic stresses affect deformation can have important implications for a range of fields, including geology, natural hazard prediction, and resource exploration. By analyzing the type and style of deformation in rock formations, geologists can gain insight into the geological history of a region, and use this information to identify potential natural hazards such as earthquakes, landslides, and volcanic eruptions. In resource exploration, understanding the orientation and magnitude of tectonic stresses can provide valuable information on the location and structure of mineral deposits. Please don't forget to subscribe to my channel and turn on notifications.